In this small video series, I wanted to go over building an infrastructure as code network to see what it's all about and just to get a feel for how it works. So the idea here is we're going to build a little network and it's going to be done purely with code. We're not going to run any commands via the command line or configure it any other way except through code, and we're going to use Ansible as our main tool to do that. I chose Ansible just because it's fairly easy to learn, so the barrier to entry there is pretty low, and it's kind of easy. It's pretty flexible. I just kind of liked it, and it's very popular. So we're going to go with that to build the network. And in our case, we're going to fully automate the whole process from booting the device up for the first time to, configuring eBGP connections to the ISP. And I do have a little topology here, wanted to go over just to see what we'll be doing, which is right here. So it's fairly small, but again, we're going to configure all of this except for the ISP router through code. And Ansible has a Python backend, so if you're familiar with that, there'll be a lot of logic in there that's kind of Pythonic. So for our topology, we're gonna have PC1 on VLAN 10, PC2 on VLAN 20. They're gonna go up to this switch here. This is just gonna be a layer 2 switch. It is a Catalyst 9000, and so is this Catalyst 9000, PC2, VLAN 20. The default gateways are gonna be respectively these routers. This is a sub interface, so gig 1.10 or whatever interface this is. And then these are routed links up here. So they have IP address on each side. And the links I'm using here, it's going to be like 10.255.12 is this link. And then this is .1, this is .2. And that's kind of how it works. And I think this one's .9. So the routers are going to run EIGRP as the routing protocol to exchange routes with each other. That's how PC1 will ultimately be able to talk to PC2, and then we'll have a eBGP connection up here to the ISP. The ISP router is pre-configured, just like it would be in real life, and so hopefully the eBGP session will come right up when it's ready. So how we're going to connect to the network, and then the content of this rest of this video is going to be going through the ZTP, the zero-touch provisioning process, which is where you can take a device, rack it, plug it in, turn it on, and then you don't have to console into it or anything. It's going to rely on DHCP to give it a value, and then it's going to take that value, which is an IP address and a name of a file, and it's going to try to reach that destination, pull a script down, and then run it on itself. That's the zero-touch provisioning process. And how we're going to do that is through these connections. So these are going to be the kind of the out-of-band management connections. So these switches, they have a gig 0, and then the routers, they have a gig 4, and we're going to kind of turn those into a management port by putting a VRF on them. So again, in the real world, you may ship this somewhere and just tell somebody to rack it, stack it, and plug in the management interface to maybe an existing switch or to maybe a WAN circuit. And once that's plugged in, once they boot it up, it'll get a DHCP from somewhere. In our case, it's going to be right here. But if you're on a WAN circuit, you can configure an upstream router, an existing router to do that. But we want, somehow there has to be DHCP on that segment. And then here's how the ZTP is going to work. So let's take router 2 as an example. It's going to be powered on, boot up. It's going to go through an auto install method where it's going to, it's going to look for something. It's going to send DHCP out its interfaces. In this case, it's going to get a DHCP address from this server, and we're going to have 2 key fields here that need to be configured on the server. And let me show you what that looks like. And here is the DHCP server. We can see we have our R1 scope, and then under the scope options, we need 2 here. 150, which specifies an IP address. That's going to be of in our case, TFTP server. And then the file name of the script that's going to be downloaded. It's a Python script. and it's going to be downloaded and ran on the device. So the flow is the router comes on, gets a DHCP address, which includes those fields. This router then knows to reach back out to here and pull that script down and then run it. Now, what does that script look like? So let's pull that up now. So this is a Python script. It's fairly simple. The first thing it does is import CLI. That is this is something that's kind of unique just to this particular use case. It's not something you can really pip install. It's just used for this ZTP process. Then we're going to print to the screen. We're going to print PyScript downloaded and running. So what I'll do is connect to the console, not to make changes, but just to view this and any other changes. And maybe we'll run some verify commands. But when this is printed on the screen, we'll know it's running. And then this is something that we'll have to keep track of. So if we have a device that's expected to run through the ZTP process, we'll have to log into our TFTP server, put its serial number in here, and then I've got two things that we're going to give it. Just a host name that we want to give it, and then its management IP. And so once it's done through the ZTP, we can take this out, but you'll want to keep this to what you're expecting to come online, because each network device is going to run the same script, and what we're going to do is build logic so the device can figure out which one it is. And that's going to happen right here. So we're going to have the device do show inventory, and then it's going to store the result here in the serial variable, and then we're going to loop through the devices, and then it's going to look and it's going to say, do I see this in that result? If so, I know I'm router 1. It's going to set a device variable to this list, whichever one it is. Then at this point we know which device that it is. And then we've got some commands defined depending on what it is. So I've got two different ones just for a switch and for a router. We'll come back to this. And then here's how it's going to know which one to pick. So now we know what device we are, kind of, as far as what our host name and IP is. Now we need to figure out, am I a switch or am I a router? And so we're going to run show inventory, and then we're going to look in the result. If we see 8000V, we know we're a router. We're going to run the router commands. Otherwise, we're going to run the switch commands. And so this works for in this little simple topology. You can make this script tailored more or less to your use case, but in my lab, I'm using 8000V for the routers. So when it's all done, it's going to run show IP interface brief, and it's going to print that to the output of the screen. So we can see when it's done, we'll see a big show IP interface brief output. Now, as far as let's look at the commands that it's going to put. On the router, it's going to put a username and password, which is going to be Ansible, domain name, host name, and now here's where it's going to get device and then first item in the list. So if I'm this device, there's where it gets this from. And it's going to create a key so we can SSH to it. And SSH version 2, secret, authentication, make sure only SSH is allowed. And then here we're going to create a VRF, make sure we can put IPv4 addresses on it, assign it, give it an IP address, and then put a default route for that management VRF. At this point, we should be able to SSH to the router. It should be fully on the network and reachable. Now, it doesn't have much config on it, just what we gave it here, because we're going to do the rest from Ansible. And switches are going to be the same way. The key difference is the switch has a VRF on it already, so all I need to do, I don't need to create it, I just need to stick an interface in it, which is gig00. And then this is going to look a little bit different. So switches, when they run this, they will be, again, on the network and ready for us to SSH into, or in our case, we're going to control it and configure it with Ansible. So I think now we can turn these routers on. They haven't been turned on yet. I do have them cabled in already, but we're going to turn them on and hopefully they will go through the ZTP process. So let's find out. So I'm going to start by powering on router 1 here. So here the router it noticed that it has no startup config. And so now it's going to go through some of these methods of auto install PNP ZTP. So in our case, ZTP. PNP would be for like a DNA center. Okay, so here it's trying DHCP on its interfaces. Here we can see it got an IP and it extracted those two options here. So there's the script file name and the TFTP server. It now knows it needs to reach out, download the script. So here's obtain TFTP server address. And then it will spin up IOX, which is the environment. It's called guest shell. It's the environment that the Cisco devices, they run their Python script in. So they spin up a kind of a access to their Python interpreter. It's also important that we don't hit any buttons on the terminal at this point, because if you start hitting buttons, it does cancel the automatic provisioning out. So I'm not going to do that, but I just want to look and watch the progress. So we're consoled in for that purpose only. Okay, here we can tell our shell's activated, guest shell's enabled. So it's running the Python script. There's the Py script downloaded and running. And there's some output of some of the commands that we gave it. And then there's the show IP interface brief. So this is router 1's done, completed, should be on the network. There's our 10.11.51, which is our out-of-band management IP that we connect to the device from. So this should be reachable. If we look at our diagram, let me go to the out-of-band. So this network here is the 10.11. It's a /16 network. And I've got all these at 10.11.50. This is 1.2.3, and then this one's .4, and this is .5. So that's how we'll connect to these. So this one's done. Let's boot up, spin up router 2 now. All right, here we can tell router 2 is starting to go through the same process. It's detecting no startup config. And so it should be kicking off these auto methods to try to discover a way to get itself configured. There's DHCP. And here's the system dialog. Just remember, don't hit anything. There it is. I'm also gonna go ahead and open up router 3 to get it going. Router 2 now looks to be complete, as we can see the output there. And I'm going to go ahead and turn on the switches to get them going. So at this point, all the devices are booted up and they've went through the ZTP process. So here's router 3. There's the show IP interface brief. We can make sure our Ansible connections work here. There's router 3. Let's see if we can log into switch 1. Okay, switch 1 looks good. Switch 2, we're going to assume that's good too. So what we can do now, if we look at our diagram, we're going to be the engineer here. And we have a machine. It's just Ubuntu Linux. And we're going to do all of our work from it. So let's test to make sure we can get to these devices. So here's our machine we'll be working on. See if we can ping router 1. Looks like we can. Just switch 5. Okay, and then let's make sure we can SSH to router 1. Okay, we are here. So it looks like we have good connectivity to our devices. Let's just check 2 and 3 and 4. Okay, so we do, looks like they are all on the network. They've all went through the ZTP successfully. We can reach them from our control node, and we haven't, ran any manual command commands. So in the next video, we're going to set up Ansible on this machine here and make an inventory file, and then run a few little playbooks just to run and test some connections and run some commands on the devices, all from this machine here. But that's going to wrap this video up, which is just the ZTP and talking a little bit about the overall remaining videos.